Okay, welcome everybody to our network design lecture. Today we're going to talk about the developing network security strategies. Today's session number 10. All right, so throughout the semester we discussed many techniques that we can use to design our network topologies, to design our computer networks for multiple purposes. Now, in today's lecture, we're going to be focusing on the security design side of things. So we're basically going to discuss how we can still address security while still developing and designing a network that is suitable for our needs. Now, network security design is a 12-step program. The first step is to identify the network assets. After that, we analyze the security risks, analyze the requirements and trade-offs, develop the security plan, define a security policy, develop the procedures for applying the security policy, because the security policy has no value if we cannot put it into practice. We're going to develop a technical implementation strategy as well, achieve buy-in from users, managers, and technical staff, train users, implement technical strategy, and test security, and last but not the least, maintain the security. We're going to discuss about each one of these in this lecture. So let's get started with the first one, which is the importance of network assets. Now, basically, we cannot protect what we don't know we even have. Okay, so imagine this. If a company doesn't know exactly what servers, what computers, what devices they have connected to the network, they won't be able to protect all the points in the network. So if we can't protect one of the points in the network, and that could be a server or a computer, a laptop or whatever, we basically have a vulnerability in the network. And this vulnerability can be used to then infiltrate the network and basically start causing a havoc in the network. Now, before we actually start connecting things to a network, we need to understand what things we need to plug in to a network. We need to understand what devices need to have access to the internet, for example. We need to understand what devices need to have access to the internal resources of the company. It could be that the company have a shared folder structure. So all the files and folders, they're located in a central repository, such as a Microsoft Windows Server 2019, for example. So all of the computers, they need to have access to the central repository of files, the server. So we basically need to understand what devices will be connected to the network at a certain time. When we try to understand the network assets that we have, it's not only about understanding that we need to have a list and we need to know every hardware that we have, but the software is also important. And that is because you guys understand that hardware doesn't necessarily mean the amount of operating systems we have due to virtualization, for example. And that's why we also need to understand all the software applications, if we're running virtual machines or not, how many virtual machines, how many operating systems we have in the network, and so on and so forth. One more important aspect of identifying our network assets is finding out the applications that we currently rely on. It could be that we are running SNMP, for example, to manage devices. It could be that we have remote desktop protocol to access remote computers and so on and so forth. So basically, when we know the applications that we need, we can better prepare our network and we can better secure our network against attacks. We also need to understand the flow of data that is coming in and out of the network. That is also going to help us find out if there is data exfiltration, for example, if there's someone sending data outside of the company, and so on and so forth. One more thing we need to understand is there any intellectual property in the company that is located into a certain server? We basically need to understand the intellectual property, because if there's intellectual property, we basically need to invest more in securing this server and so on. The same goes for trade secrets and company reputation as well. So basically, the company's reputation is relying on how secure the network is. If we don't understand what we have in the network, we are not going to be able to protect our systems and servers and computers properly. So we need to understand that. We need to have our network asset list in order to protect our devices. Now, what is at risk here is the company reputation. So a few years ago, Yahoo suffered an attack and basically leaked many user accounts and passwords and so on, including personal information such as date of birth and so on. Now, as you guys may think, nowadays people hardly want to have Yahoo accounts anymore because of this incident. So it just basically ruined the company's reputation, because if someone doesn't trust the company in terms of security, the person is not going to choose their services and so on. So company reputation is at risk here. How about the security risks that we have and how we can understand the security risks? Now, this is not a cybersecurity course, so it's not going to teach you all the nitty-gritty details about cybersecurity, but it's just basically going to give you an overview of security and the things that you should be aware of. Now, hacked network devices, they are a huge risk to a company, and that is because they can be used to intercept data. They can be used to analyze data. They can be used to alter data or even delete data. Okay, so they're high risk. So no one wants to have any of the computers in a company hacked, because one computer, it doesn't matter which computer is it, it could be a vector for attacks to all other company computers, servers, and resources. Now, hacked network devices, they can also offer user passwords that can be compromised. So if a user password is compromised, that usually means that all the other devices that have the same password, they are always also compromised as well. Now, hacked network devices, they also can make changes to device configuration, and they can also be pivoting. They can be pivots for all the network attacks. So just the same example I mentioned to you guys before. Now, if someone hacks one device, it may seem like that device is not special. It may seem that that device is just a user client, but because this user client is connected to the entire network infrastructure, someone can use this computer as a vector, as a pivot for attacking all other networking devices, because now the attacker is inside of the network. Now, all the security risks that we may encounter include reconnaissance attacks. Now, reconnaissance attacks, they are targeted to understand how the network infrastructure looks like, to understand what devices are connected to the network. Other type of security risks that we may encounter is denial of service attacks. Now, denial of service attacks, they are usually focused on causing disruption of service. They are usually targeted to basically compromise servers, compromise host machines, so that legitimate users are not able to access the resources that they need at the time that they need them. Now, security is a huge topic nowadays. Everybody's discussing about security. I'm going to tell you that the IT professional of the future is not going to be specialized just in one thing. Now, 10 years ago, 20 years ago, someone that used to be a network engineer would just deal with the network and configuring networking devices and so on. But nowadays, because the security threats are growing and growing, the network engineers, the programmers, and everybody that works in IT needs to understand the security risks and need to actually start implementing the services by considering how security can be implemented and how secure the devices can be using appropriate technologies. So you guys are studying, hopefully you guys in the future will become network engineers. Now, it's not the end. You're not going to learn all about networks and that's the end. You're going to have to keep updating yourself in terms of technology and also in terms of cyber threats and how you can actually mitigate attacks and so on. Now, of course, security measures that someone can take, they are endless. So you can basically take many security measures to make your device as secure as possible. For example, you can basically set up a password which is 100 characters in length. And obviously this password is going to be harder to crack than a 10 character in length password. However, there is a huge trade-off if you choose a 100 character password. And the trade-off is that it's not going to be usable. On a day-to-day basis, people are going to be really upset that they have to type it in a 100 character password. They don't care how protected the network is. They don't care if you tell them it's basically unhackable, uncrackable. It's a 100 character password and so on. It's gonna take ages for someone to try to crack that. They don't care. If a password is not usable, if it's not, user friendly, pretty much no one cares. So taking care of the security system in a network is a huge responsibility, because all the time it's about making trade-offs. It's about sacrificing affordability to make sure you have better performance. It's about sacrificing availability in order to have a better manageability, for example. So it's all about putting everything in a weight scale, and you basically start weighting every single one of these aspects, and then you try to find out a balance of things that you want to do in your network. Now, we already discussed these terms before when we discussed trade-offs. Now, just a quick one, we still need to discuss about this. The affordability is in regards to the financial cost of implementing something, implementing a measure. The usability is how easy it is for a certain user to use a certain resource. The performance, don't need to describe the performance for you guys. Availability is just basically making sure the services are available to users, and the manageability, making sure the devices can be easily manageable and changes can be easily made. Now that we discussed about the trade-offs and the huge responsibility that we have to try to find out a balance, we need to focus on something called a security plan. Now, a security plan is a high-level document that proposes what an organization is going to do to meet security requirements. So it's basically a first step in an organization when an organization actually cares about security, okay? So it's basically the first step is when they take ownership of the problem and they say, we need to do something about it. We don't want our company's network to be hacked, so we need to do something. And this something that they do is basically the security plan. They come up with a plan. It's a high-level document. It doesn't specify details, but it's basically going to say, we need to do this because security is critical for us right now. Now, the security plan will usually have time. So it might be that the company wants to implement security within a year. It will include the people involved in the process and all the resources that will be required to develop a security policy. So usually a security plan is the first step when a company wants to take security seriously, and when they have plans for developing a security policy. It's the very first step. We need to do something. Other companies are being hacked. We need to make sure we're not going to be. Okay? Now we define the security policy. So after the security plan, security policy will hopefully be created. Now the security policy is based on the security handbook, which is the RFC 2196. It says that the security policy is a formal statement of the rules by which people who are given access to an organization's technology and information assets must abide. So it basically specifies all the rules that people need to follow to make sure the security baseline, the security requirements of the company are followed. It might be that from the security policy, someone is going to deploy a group policy that will say that no one can have a password which is less than 10 characters in length, and the password also has to meet complexity requirements. That could be in the security policy. Okay, so it's a rule. Everybody needs to follow the rules, and so on. Okay. Now, the policy usually addresses the access. So in terms of access, it's basically who is going to be responsible for accessing certain devices. Accountability, who is going to be responsible if something happens? Who is responsible for making sure everything is up to date, for example? Authentication, how is authentication going to be made? Is it going to be based on a server, a AAA server that is going to be authenticating all the devices? Is it going to be locally? Every single device will have a username database for authentication purposes. How is authentication going to be done? Privacy as well, and computer technology purchasing guidelines. It could be that certain specifications for the operating system, if a cybersecurity specialist that was involved in the security policy says that a certain operating system should not be used because of certain vulnerabilities, that's also going to be highlighted in the security policy as well. All right. So if you really want to be in cybersecurity, I don't know if any of you guys are interested in cybersecurity. If you're going to be a cybersecurity specialist, or you really want to dive deep into cybersecurity, you're basically going to be studying more about the policies themselves, about how you actually write these documents, the security policy. What are the things that you should be aware of when you're writing the security policy? How do you investigate the technologies that you basically need to rule out of the organization? How you make sure that the devices are up to date with the latest operating system that doesn't have a certain vulnerability, and so on. All right, security mechanisms. Now, because we're not necessarily cybersecurity specialists, cybersecurity analysts, we are not actually interested in writing down the security policy, in writing down the rules. We are more interested in knowing how we actually put them to practice. Now, in terms of physical security, so how are we going to make sure our server is physically secure? Of course, we're going to follow the guidelines specified in the security policy. They might say that the server needs to be locked in a server room, and so on. Authentication and authorization and accounting, AAA. What does the security policy talk about AAA? Is AAA being used? Are all the users supposed to log in and authenticate through a server, through a Windows Server environment? Are all the users supposed to authenticate locally? And so on and so forth. So you basically need to understand AAA and how we can implement AAA. Now, one interesting thing about AAA is we don't talk too much about this in our networking courses at CIT. We mostly discuss about SSH. We mostly discuss about creating a username password on a specific device, for example, a switch or a router. Now, if you think about an organization, it's not very manageable if you have all the username passwords on local devices. Okay, it's not manageable because you're going to have to create the username and password on every single one of the devices. And sometimes this can't be done because you have 1,000 devices, 2,000 devices. So what we actually do is we rely on to a AAA server that is going to store all the username password pairs for all the users. And then all these networking devices, they can authenticate using this AAA server. All right. Another thing that we need to worry about is data encryption as well. How is data going to be encrypted? Now, we studied many technologies, for example, HTTP, HTTPS, Telnet, SSH, and we differentiated these protocols based on the encryption capabilities. For example, we should not use HTTP because it's not encrypted. We should choose HTTPS whenever possible. And the same goes for Telnet as well. We should avoid Telnet at all costs and go with SSH whenever possible as well. And that is basically because we want to make sure our data is encrypted, because our data is going in and out of the network all the time. And sometimes we have no idea where is our data going to. When the data reaches the internet is just like this huge sea, and we cannot track everything that goes from one router to another router in the internet service providers. So we don't know what's going to happen to our data. So we want to make sure our data goes to the ISPs and goes outside of our private network encrypted. We also want to make sure we worry about the packet filters and how we're going to filter out unwanted traffic. And that is usually done through the use of firewalls. And now we talk about two intrusion systems. The first one is the intrusion detection, and the second one is the intrusion prevention systems, IDS and IPS. Now, if you actually go for a cybersecurity certificate in the future, if you want to do a Cisco certified cybersecurity operations or something like that, you're actually going to have to dive deep into the difference between an intrusion detection system and intrusion prevention system. I'm just going to tell you the basic difference here, which is that the security detection system is usually not going to stop the traffic. It's only going to flag the traffic. It's going to say there is an issue with this traffic, something needs to be done. Now, the intrusion prevention system will actually identify the traffic that is unwanted, the traffic that is trying to come in the network with malicious intent, and the intrusion prevention system will be able to stop the traffic before the traffic actually reaches a device. Okay, so that's the basic difference between IDS, IPS. Firewalls, I think you guys are pretty much familiar with firewalls. It's basically filtering packets, filtering traffic based on certain rules. Now, these rules that the firewalls they are usually based on the port numbers and sometimes also IP addresses as well of the source and the destination. Now, why encryption? Why do we need encryption? Now, encryption is basically the fundamental of something called confidentiality and integrity. Okay. Now, if you've ever studied cybersecurity in your life, you know that the fundamental of cybersecurity is something called the CIA triad. Now, the CIA triad is basically three concepts that we need to make sure we have in our networks. C stands for confidentiality, I stands for integrity, and A stands for availability. Now, confidentiality just basically means that people that are not supposed to have access to certain information won't be able to read it. And that is done through encryption. Integrity, it's something similar to encryption, but don't get confused here because they are not the same thing. Integrity comes down to making sure your traffic hasn't been modified from point A to point B. Okay? That's basically, and what is the technology that does integrity? It's hashing. So whenever you think about confidentiality, immediately think about encryption. Okay? And whenever you think about integrity, immediately think about hashing. All right? Now, if you remember, hashing is a one-way function. When you hash something, it basically means you cannot get the original message back. It is just a way that you can verify that what was created before hasn't been changed. Okay? Now, I don't know if you guys seen this before, but some websites, when you try to download a software, some of the vendors, they actually include a hashing algorithm in the message. They also include a hash. So, for example, it could be hashMAC, it could be SHA or MD5 or something like that. And that is just basically the hashing algorithm that is used to verify the message integrity. So what happens is a company will take the software and will send you the software, will make the software available with the result of the hashing function for that specific algorithm. So if the algorithm is MD5, for example, it's going to specify how you can hash the message. So what they will basically send to you is the original message alongside with the result of the hash. And then what you can do is at your end, you will take the original message, you're going to apply the hashing algorithm, MD5 for example, and if you get the result, which is the same result that they actually sent to you with the original message, you know that the message hasn't been modified. We also do have the encryption. Encryption, I'm pretty sure you guys know, you basically take the information and you hide it. And how do you hide the information? By changing characters, for example. So you can say that every A is not supposed to be an A, it's supposed to be a 5. Every B is not supposed to be a B, it's supposed to be a 6. So you basically transform the message into something else. If someone actually checks the message, they will not be able to make sense of the message because they don't know how the message was encrypted. What were the techniques used to hide the message from unauthorized users? Now, public key and private key is basically the fundamental of how we send data through the internet. Now, public key, private key is a asymmetrical technology. It basically means whenever I encrypt the traffic using a public key, I can only decrypt the message with the private key. That's how it works. Now, the opposite is also true. If I encrypt the message with the private key, I can only decrypt it with the public key. And what does that mean? The public key is widely available to the public. Everyone can have the public key. Everyone. Okay, so you can actually go to a website and find public keys for many different services. Now, the issue is it's not a problem that everyone knows the public key, because the public key cannot be used to decrypt a message that was encrypted using the same public key. In order for us to decrypt the message that was encrypted with the public key, we need a private key. And here's the secret. The private key is only at the server side. The server is not going to share the private key with anybody. And how does the server know it's you? Because you encrypted with the public, only the private can be used to decrypt the traffic, and the private key is only known by the server. And that's how you can guarantee your data is going to be confidential. No one is going to be able to take the message, read it, and make sense of it because it was encrypted using a public key. It doesn't matter that they have another public key, the same public key. They cannot decrypt the data because it's asymmetrical. Remember, one key is used to encrypt, another entirely different key is used to decrypt. Okay? Now, one more thing that the public keys and private keys, they do for us, it's something called digital signature. Now, when someone actually, so we can prove to the server that we are who we say we are based on a public key that we send to the server. Only the server have the private key to decrypt it. And that's how we basically make sure our data is confidential. But how can we make sure the server is who he say he is? How can we make sure Google server is actually Google server? When we want to make sure who is the origin of the message, we do this using digital signature. And digital signature is just the opposite of data confidentiality. Instead of using the public key to encrypt it, we are going to use our private key that only we know about, and then we're going to send it out. Now, someone on the other end will use the public key to make sure that we are who we said we were. Because if we are who we say we are the only people that are supposed to have the private key, because the private key is not revealed to anybody else. All right? And this is how the digital signatures work. Okay? Modularizing security design. Now, we discussed about many things. Now, we could do many things to make sure our network is secure. Now, the thing is, what are we going to do? Are we going to set better passwords? Are we going to make sure everything is encrypted? Are we going to make sure we have hashing to make sure we guarantee message integrity? Are we going to use SSH instead of Telnet? Are we going to use HTTPS instead of What are we going to do? Now, if we do certain things and don't do other things, we are basically relying on to one layer of defense. Okay, so everything that you do to make your system more secure is a layer of defense. It's one measure that you can take to make sure your system is more secure. Now, as you may be thinking, if you do something and you don't do something else, if you get hacked at one point, someone is going to be able to do whatever they want in the network. So if you're relying on SSH and nothing else, and you're using the most stupid passwords ever, you're still vulnerable. it doesn't matter that you're using SSH, your devices are still vulnerable to other types of attacks. Now, lucky to us, there is something called the security defense in depth model. The defense in depth model, it's basically a model that says, whatever you can do, do it. Okay? In other words, whatever you can do to make sure every single one of the devices, technologies, and layers of security are addressed, you are going to have to do it. And that's why it's known as a multi-layered design. Okay, you're going to do as much as you can to make sure your devices are protected. So it's all based on the belt and suspenders approach. Don't get caught with your pants down. Okay, so if you do something and you don't do something else, you're gonna get caught with your pants down. Okay, and you don't want to get caught with your pants down. It's shameful. All right, so you're gonna make sure you protect your devices everywhere. You want to make sure you understand the layers. You want to make sure you understand the OSI model. Because if you understand the OSI model, you guys remember the OSI model from the first lecture? You have 7 layers: physical, data link, network, transport, okay, and so on. Application, presentation, session. So you know all these layers. You know that if you protect one of these layers and someone is able to hack a specific layer, they can basically come inside of the network. All right, and we don't want to do that. So we want to make sure we protect all the layers. Modularizing the security design. Now, secure all components of a modular design. These are the things we're going to be paying attention on, okay, when we're designing our network. We're going to pay attention on the internet connections because we want to make sure the internet connections are secure. If we have public servers and e-commerce servers, we need to make sure we position them in our location in our network, that if that location gets hacked, it is not going to allow someone to hack the private network as well. Okay, and we're going to discuss how we can do that in a few slides. Network services and network management as well. How are we going to manage devices? How are we going to provide the services in our network? And we also have user services and wireless networks. There is something called the Cisco Safe Security Reference Model. It addresses security in every module of a modular network architecture. Now, we discussed about the defense in depth model. So we basically need to make sure we protect many layers in our network to make sure our systems are as secure as possible. Now, we can basically start designing our security policy or even evaluating a security policy based on the Cisco Safe Security Reference Model. It will basically tell us what are the things that we need to be aware of and what are the things, the places in our network that we need to make sure we take security measures to make them protected. All right. So, for example, we do have management. So, through the use of management, we can make our campus network more secure. Basically, talking about the private side of our network. At the same time, we also need to make sure our WAN edge is protected with the security protocols and technologies, extranet, and so on and so forth. So basically identifying all the places in our network and every single one of them that we should take measures to make sure they are protected. Security internet connections. Now let's talk about this. Now, physical security is extremely important. All right. Firewalls and packet filters, audit logs, authentication, authorization, well-defined exit and entry points. If we don't understand which devices are connected to the internet in our private network, we are not going to be able to filter traffic that is unwanted. And by unwanted, I mean bad traffic. Okay, someone trying to hack you. Okay. So we need to make sure we have well-defined exit and entry points in the network. And we also want to make sure we are using routing protocols that support authentication. Cool. Securing public servers. Now, Public servers, they are the servers that we have in our network that are going to be available to people from the internet. So usually websites, some companies, they have web servers that are available to the public. They don't want to pay they host server. So what they do is they host the web page in a central location. It could be on the premises or whatever they want, but that basically means this server has to be in a point of the network that is not private. Okay, these servers, they need to be in something called the DMZ. The DMZ or DMZ is the demilitarized zone. It's a place in our network that is not well completely protected. Okay, it doesn't have the same rules that we have in our private network. In our private network, we don't want to allow anybody from the outside world, anybody coming from the internet to access any resources. Now, all the servers that we're going to position in the DMZ or DMZ, they are the servers that we're going to make available to the public. All right. So, and because of these, the rules, the traffic rules, the traffic filters that we apply to the DMZ, to the server farm, or whatever, will be different than the rules that we apply to the private network. All right. For example, if we do have a web page in our server, we're going to put this server in a demilitarized zone, in a DMZ. Now, these DMZ will allow people to come in and access the ports 80 and 443 of the web server, for example, HTTP and HTTPS. All right. Now, we don't want to have these ports in our private network opened because they can be a vulnerability. After all, we have no web server in the private side of the network anymore. Our server, our web server, is on the demilitarized zone. Now, make sure you understand this because on the third assessment, you have to deal with the demilitarized zone and you have to position the servers at a location that they're supposed to be to allow remote access from the public side of the network. Now, when we talk about the DMZ, the DMZ, we are going to run a firewall on the server itself. Now, however, we are only going to allow the ports of the services that we are offering. For example, if we have a web server, there's no reason for us to keep ports 22 and 23 open, Telnet SSH. We are only going to have 80 and 443 open if we're offering HTTP, HTTPS, and so on. So we do have firewall rules running on the public server still, but they're only the ones that are necessary for the server to allow access to remote users. Now, we also need to make sure we enable a denial of service protection on the public web servers because they're publicly available to pretty much everybody that is connected to the network. We want to make sure we have certain types of denial of service protection. For example, if someone tries to refresh a web page, request a web page 1,000 times within a second, that is clearly an attempt to overwhelm the server. So we can basically set up some rules to block access if someone tries to access the same server multiple times within a certain time frame. Another thing we want to make sure we do in the web servers or the servers that are located in the DMZ, we want to make sure they are running a reliable operating system with the latest security patches as well. And also, we want to make sure we maintain modularity when front-end web server doesn't also run all the services. All right. Now, let's discuss about these security topologies of where we can position our demilitarized zone. Now, usually what we have in an enterprise network environment is we do have an entry point in the network, which is basically all the traffic that is going to coming in from the internet or going out to the internet. And then we have our private network. So this is just basically the ISP that will give us access to the internet. Now, where are we going to position our DMZ servers, our servers that are available to the public? So if we do have a web server or a file server that is available to users outside of the private network, or if we're offering DNS or mail servers for users outside of the organization, we want to make sure these servers, they are in a region of the network that is not as well protected as the enterprise private network. So everything that you guys can see here to the left, which is called the enterprise network, is actually the private side of the network. Because after all, the DMZ is still part of the enterprise. All right? And we do have the entry point. Now, there's usually a name for these router that connects the entire infrastructure to the internet. If you don't know the name of these router, it's called an edge router. Okay? So every time we have an edge router, or we refer to an edge router, is the router that connects everything in the enterprise or in your house, for example, whatever, to the internet. That's called an edge router, or to other networks, doesn't matter. Now, in this specific design here, in this specific topology, we do have a firewall here in the middle between the edge router and the enterprise router. Okay. Now, this enterprise router is connecting the private network. All the devices connected here, they are private devices. All the devices here, they're made available to the public. Now, this device here, what is this? Is this a wall? What is this? Okay, this is not a wall. It is supposed to be a device. Now, the firewall is usually represented as a wall because it could be a software, okay? It could be a hardware, okay? It could be that this is not even a firewall just like this. It could be that this is actually the rules applied to the servers, okay? The firewall rules apply to the servers. And then connects the private, and then the firewall rules applied here to the enterprise network, they are completely different than the rules that we have here in the DMZ. Okay. Now, this could be a hardware firewall. Okay, we do have some advanced security appliances hardware, the Cisco ASAs. They're actually physical devices that we can actually connect wires, and then they do all the firewall rules. All right. Now, this is one way of doing this. Another way that we can do it is that sometimes we don't actually have two routers in the network. We have only one. So that just basically means everything, including the DMZ and the enterprise private network, they're going to be connected to the same edge router. I'm going to show you this topology right now. So this is the topology I'm talking about. So we basically, instead of having a router that connects us to the private side of the enterprise network, we only have one edge router that is responsible for connecting the DMZ and the enterprise networks. Now here, once again, this firewall that is represented by these red wall, a few bricks and stuff, this one is actually the rules. It can be a hardware, it can be a software. It's up for the organization to decide if they have enough money to spend in buying an advanced security appliance or something similar to that. They can actually have a hardware firewall, okay, and make the connections. Now, if this is not a hardware firewall, it's just about the rules that we apply to the software firewalls that we have in the DMZ and the enterprise private network. The rules are different. All right, securing remote access and virtual private networks. Now that we discussed about that, now there are many ways we can secure remote access and virtual private networks. The first thing that is important for us that we should never overlook is the physical security of everything. We want to make sure our servers, they're located in a safe place. We want to make sure only people that are supposed to have access to the resources, they do have access, and so on. Now, firewalls as well, authentication, authorization, and auditing, we already discussed. Encryption, one-time passwords, and security protocols should be used as well, including CHAP, Radius, and IPsec. Now, one thing I'd like to discuss here is this, the router firewall, the router with a firewall. Now, Cisco has something called the zone-based firewall. A zone-based firewall is actually rules that you can implement in a router. Okay, so the Cisco iOS router has actually this capability called the zone-based firewall, and that basically allows us to have different zones in different interfaces of the router, and then we can create the rules, the traffic rules, whatever we want to allow, whatever we want to deny, based on the zones that the interfaces are connected to. So in the previous example here, for example, this doesn't need to have a hardware firewall. It doesn't need to be a hardware firewall. It doesn't need to be software implemented on the host machines themselves. We can actually buy a zone-based firewall router, and then we can configure the interfaces of the router to have different traffic filter rules. All right? We can create the zones. We can then create the rules that we want to establish for certain zones. All right. Security network services. Now we need to treat each network device, including routers, switches, and so on, as high value hosts and harden them against possible intrusions. So you might be thinking, why do I need to set up a password on a router or on a switch if pretty much no one is going to be accessing the device? Okay. Now, this is a misconception. You should always consider routers and switches as just as important as pretty much everything else in your network. So in the production environment, guys, please don't set up the password to be Cisco 12345 or Cisco class or whatever that is, okay? Make sure you take it seriously. Make sure you follow the security policy guidelines on what the passwords on the devices should be. And when I say devices, it applies to routers and switches as well, okay? Does it have to be 10 characters in length? Does it have to meet complexity requirements? That's the password I'm going to set on my network devices. Require login IDs and passwords for accessing devices. Use SSH rather than Telnet, and change the welcome banner to be less welcoming, all right? So usually in the production environment, the welcome banner, if someone is actually able to get to the welcome banner, it means the person has actually some understanding of networking devices, and that means the person is actually a potential threat to the network. So you want to make sure you display a message to this person saying that the device is protected, saying that someone is going to be prosecuted to the maximum extent of the law, something like that, okay? Securing the server farm, deploy the network and host IDs to monitor server subnets and individual servers, configure the filters that limit connectivity from the server, fix known security bugs, and how you're going to do that, making sure the servers are always up to date with the latest patches and fixes, require authentication and authorization for server access, limit the root password to a few people, okay, that's just basically based on the principle of least privilege. Pretty sure you guys heard about the principle of least privilege on other courses, but it basically tells that we are only supposed to give privilege to a person to do whatever they have to do, okay? You're not going to make everybody an administrator account if they don't need to administer everything. Avoid guest accounts as well. So all of those build accounts should be avoided. Securing user service, specify the applications that are allowed to run. Now, this securing user services side is usually accomplished through the use of group policies and firewalls as well. Another thing that we need to do is require personal firewalls and antivirus software on network PCs. Encourage users to log out when leaving the desks, or we can actually configure group policy to lock the devices after a certain amount of time in idle. And we're also going to consider using 802.1x port-based security on switches. More about 802.1x in a few slides. Now, we also need to make sure we secure our wireless networks. All right, now let's discuss about wireless security techniques. Now, we should place wireless LANs, WLANs in their own subnet or VLAN. And that is basically because we can then deal with the firewall rules much easily if we have them in a separate subnet, in a separate VLAN. It simplifies addressing as well. It makes easier for us to configure packet filters and so on. We should require all wireless and wired laptops to run personal firewall and antivirus software. We should disable beacons that broadcast the SSID. So if you guys know what the beacons are, they're basically the router sending signals saying that the router exists and is capable of doing wireless services. Now, sometimes it's not cool for us to broadcast these beacons all the time to tell people that we actually have a wireless network for them to connect. Okay. Usually what's done in a Wi-Fi protected network is that these SSID or the wireless broadcast messages, they are hidden. Okay. So in order for us to connect to a wireless access point that has a hidden SSID, we need to know the exact name of the SSID and we need to know the password. Because after all, the router or the wireless access point is not going to be sending these signals all the time. Wireless LAN security options that we have the WEP, wired equivalent privacy, Wi-Fi protected access, WPA. None of these should ever be used by you guys. Okay? They are weak ways of authenticating yourself to gain access to a wireless infrastructure. Now, we do have Wi-Fi protected access WPA2 using a pre-shared key or enterprise version using a AAA server. And we do have the more advanced Wi-Fi protected access WPA3. Now, the difference between the pre-shared key and enterprise technologies is that the pre-shared key is usually configured on the device itself. So one example of this would be the one that we have in our houses. Okay. The modem, the router that we receive from our ISP is usually configured to be a pre-shared key. Okay, so we usually have to type it in the password. This password has been configured on the device, and if we type it in the correct password, we're going to gain access to the wireless network. Now, in an enterprise environment, we don't want to have this because otherwise we're going to have to be creating user accounts, we're going to have to be creating passwords for multiple people, and that is not scalable. Okay, so the WPA2 enterprise or WPA3 enterprise allows us to have all the username database in a server, and this server is a AAA server that will then authenticate the users for them to gain access to the network, to the wireless network. Now, is there anyone here that have connected to the wireless LAN at CIT? Wireless LAN at CIT. Is there anyone here? So you know the wireless LAN at CIT, you guys actually have to type it in your username and password, right? Now, is the password the same for all the students? It's not the same for all the students, right? So it's not pre-shared key. Now, let's compare this one with the one that we have at home. When we want to connect our phones to the wireless LAN that we have at home, we need to type it in a password, right? And this password is the same password that we're going to give to someone that comes to our house. So if you have a friend coming over to watch a movie or something like that, the person will usually ask you for the Wi-Fi password, and you're actually going to give them the same shared key that you use to authenticate your phone. Okay? And as you may be thinking, this is good enough for when you have a small company or a small enterprise. Now, when you have a big organization or when you have too many users, such as the users that we have at CIT, the students, the staff, we want to have a central location with all the username and passwords. And this is the AAA server. All right. So instead of typing in a pre-shared key, you guys type in your CIT username and your CIT password. And if that's correct, you are authenticated and then you gain access to the wireless local area network of CIT. Cool? Is that clear? Now, just for the record, WPA3 is still being experimented. So it's not actually a final version. And that's why nowadays most of the devices, they don't support WPA3 yet. Okay. So nowadays, if we actually have the choice and the device can only support web, WPA, WPA2, the best alternative would be going with WPA2. Now, they have differences in regards to the encryption that they use, the size of the encryption key, but in other words, the more advanced version is WPA2 and 3. All right. Now, we do have one protocol called the 802.1x, which is the extensible authentication protocol. Now, the WPA2 and WPA3, they rely on two radius servers. Now, these radius servers, they are providing the AAA, so they basically authenticate the users for people to gain access to the network. Now, the 802.1x extensible authentication protocol is a way that we can actually authenticate in the domain environment with our domain credentials. And with these domain credentials, our network access will be granted or not. So in other words, if we are able to log into an enterprise computer that is actually joined to a domain environment with our domain credentials and they are all correct, we don't actually need to type it in the password to authenticate the wireless access. It's going to be done automatically, okay, based on the authentication that we had with the domain controller, right? And we do have VPNs that should be used all the times whenever we are accessing public Wi-Fi. I don't know if I mentioned this to you guys, but there is nothing more scary than public Wi-Fi. I know sometimes we have no option, especially when we're going on a trip and we have to connect ourselves to the public Wi-Fi infrastructure of an airport or something like that. But I'm going to tell you that nothing that gives me the creeps more than public Wi-Fi, okay? And that is because we have no idea what's going on with the public Wi-Fi. We don't know what are the other users that are connected to the public Wi-Fi. We don't know if the traffic that we are sending is being intercepted. We don't know if there's a man in the middle, okay? And that's why you should try to avoid public Wi-Fi hotspots whenever possible. Now, if you do have to use public Wi-Fi, please make sure you have VPN, okay? And the VPN is basically going to guarantee all the traffic coming in and out of your device is encrypted, okay? So even if there's someone in the public Wi-Fi as well intercepting your traffic, they will not be able to actually make sense of the traffic that you're sending. Okay, wired equivalent privacy, just like I already mentioned, is an IEEE 802.11 Wi-Fi authentication standard. Users must possess the appropriate web key. So it's a pre-shared key that is also configured on the access point. It's usually a 64 to 128 bit key or passphrase. Web encrypts data using RC4 stream cipher method, and that's why it's considered weak, because RC4 stream cipher is crackable, okay? And it's an encryption algorithm that is crackable, and that is why web should be avoided at all costs, okay? Web alternatives. So if we cannot go with web, what should we do then? There are some vendor enhancements to web. So if you're configuring a wireless access point that is too old and it doesn't have WPA2 or WPA3, it just supports web, you can try to see if there is a vendor enhancement to web, such as TKIP or AES. They actually try to make the keys unique and make the keys stronger, okay? Now, TKIP has a new and unique web key for every frame, but TKIP is considered to be weak compared to AES, okay? So if you have the choice to go with AES or TKIP, AES should be the choice, okay? Now, AES is the choice for all the government-owned organizations and so on, okay? Now, we do have the IEEE 802.11i as well, and also the WPA, okay? Now, if you have the choice to go with WPA 2 or 3, just like I said, choose 2 or 3 instead of 1 because they offer enhancements compared to previous technologies. Now let's discuss about these extensive authentication protocol, or EAP. Now with 802.1x and EAP, devices take one of three roles: supplicant, authenticator, and authentication server. The supplicant is the device that wants to gain access to the network. The authenticator is the device that is going to talk to the server on our behalf. And the authenticator server is going to be the radius server responsible for allowing access to a certain network. Now, 802.1x, guys, is really awesome, okay? Now, most of the organizations, they have switches all over the place, okay? So they have a switch in one floor, another switch in another floor, another switch in another floor. And sometimes people have access to swapping around the connections on switches, or even connecting devices to switch ports and so on. Now, 802.1x is a technology that will allow us to only allow access to a certain network to users that can authenticate themselves using credentials that are stored in a radius server. All right. So if there's a radius server with all the username, password pairs for all the users, if someone connects themselves to a switch port, for example, they actually have to authenticate with the credentials they have with the domain. Could be the domain controller, the radius server, whatever it is that we have. VPN software on wireless clients, just like I already suggested, it's the safest way to do wireless networking for corporations. Wireless clients require a VPN software, connects VPN concentrator at headquarters, create a tunnel for sending all the traffic, so that basically means the entire traffic is encrypted. And the VPN security provides user authentication, strong encryption of data, and data integrity, right? Now, VPN software nowadays, guys, it's like a de facto standard for organizations that want to allow remote users to connect to the private resources, okay? So if you guys done NIA or something like that, so you might have came across VPN at some point. So you basically know how to implement VPN technologies. So you basically configure VPN server, and then the clients, they need to establish a secure connection. So they will basically build a VPN tunnel with the server, and all the traffic that goes through the tunnel is encrypted. This is a summary of everything we discussed today. So when we're designing, we need to do a top-down approach. In chapter 2, we talked about identifying assets and risks and developing security requirements. Chapter 4 talks about logical design for security. Chapter 8 talks about security plan, policy, and procedure. And Chapter 8 also covers security mechanisms and how to select the right mechanisms for different components. We do have some review questions for you guys to reflect on. And that's pretty much all.